a Monday, we might get some people.
No, Christian.
All right, good morning, e-learners. It is entirely up to them whether they do it live or watch the recording, so I don't control that part.
Wait, so they can join us?
They can join us, yeah.
Why? Oh my god. They're saying by Monday?
So most of them have not been receiving the link for the class, but they will all on Monday. So we're switching, you guys as well, we're switching to this thing called Microsoft Teams, and that's how we're going to be doing our e-learning. So if you switch to e-learning or during a snow day when we have an e-learning day, then you'll be using this program called Microsoft Teams to get the classes. And I have not added anyone, and I don't intend to add any of you guys till we get closer to snow season. I don't want to mess it up, so I want to be able to see just my e-learners. But I will be adding all of you as soon as the snow starts to fly, because I know then we'll all switch to it. Okay, whose homework are I going to use?
Mine. So right here.
All right, thank you.
Dang it.
All right, here we go. You ready? Stop me when I'm wrong. The answer number 1 is 8. I'm sorry. A is 8, B is 100, C is 4, D is 27. What's 3 times 3?
9.
Times another 3?
27.
27. All right, number 2, A is B, 5 to the 4th. B is 2 to the 7th. C is 10 squared, or 10 to the 2nd power. D is G to the 3rd power. E is either 2 to the 2nd, H to the 3rd, or 4H to the 3rd. We okay? Somebody close the door. I'm loud. F is R to the 3rd, X to the 2nd. I got you. Number 3 is 40. Number 4 is 23. Number 5 is 4. Number 6 is 10. Number 7 is 5. Number 8 is 3. Number 9 is, help me, 51? Okay. Number 10 is 2. Oh, you wrote through the X. She left off the +5. Yeah, 7, sorry. So that's 2. Number 11 to 50. Is that right? Number 12, 3.
2.
Number 13 is 2. And number 14 is 18. You have it right. You just didn't do that. 36 minus 18 is 18. Right, you missed it. All right. Count how many you got wrong for the top.
Can I pass out papers?
Okay.
Oh, wait. No.
All right, everyone else, look board, copy down your homework. When's the next important thing? When's the next important thing?
Wednesday.
We got a long time from now, right? All right, there is your homework. Copy down, please.
2 weeks on Monday.
Homework. Oh, that's going to be annoying.
Well,
The other class is compiling, so it's just taking forever. Hey, follow a sequence and you'll get it done efficiently and quickly. All right, so what are we studying? What are we studying? Somebody help me out. Exponents, thank you. So this is the second part of it. I will show you, I think it's 3 new things. What? 2 through 34 evens. Yes. He wasn't here, right? Yeah. What do you mean he didn't get his homework? She did. She literally did. Your sister got your test though, right? All right. So, David, write this down. Oh, it's a worksheet. I'll remind me. I'll give you the worksheet. Boy, your sister got one thing right, one thing wrong. I said to your sister, I said, she goes, I need his homework and his test. I said, I'll give you the test, right? And I said, walk over there and copy down the homework. And I saw her walk over there. I don't know what she did. Sisters. Jeez.
I have 1 and 5 brothers.
I had an older and a younger.
I have 5 older.
Wow.
and I have 6 young.
And I have no siblings. I'm the
Nice.
youngest. 1 older.
Then your parents got it all figured out now, right? No?
I have 2 older siblings. I'm in the middle.
And I don't
The one
have any
closest to
older
me is
siblings.
19.
All right, you ready? Here we go. All right, second part of exponents. Second part of exponents. The last class, we talked about this thing called exponents, and it's a way to show repeated multiplication. If multiplication is a way of showing repeated addition, exponents takes that to another level. It's a way of showing repeated multiplication. So I guess in some sense, you could say that's a way of showing repeated addition, right? If multiplication is repeated addition, then exponents would be repeated addition, repeated addition. Did I confuse you?
Yeah.
All right. So what do we call the big number? Call the big number the, and we call the smaller number the power or the exponent. The power of the exponent goes to the upper right. It turns out there's 4 positions to put numbers. Upper left, upper right, lower left, lower right. If you go higher in math, you will get to use the left side, right? Absolutely through high school and if you just only take calculus, you will use the lower left side. We've used the lower left side. What do we use the lower left side for? Lower right side, sorry. We use it for, it's called sub notation or subscript. It's a way of describing what you're dealing with. Thank you, Zoom, for putting boxes all over my presentation. You go away, and you go away, and you go away. All right, here we go. So, the method for converting an exponent or to simplify an exponent is you take the base, you write it. How many times do you write it? The number of times that the power is. The power is 4, I write 4 2s. If the power is 10, I need to write 10 2s. This time the power is 3, so I write 3 2s. Once I have the 3 2s written, I put multiplication in between everything, and then I multiply. 2 times 2 is 4, times 2 is 8. The one thing I will never do is, I will not do the base times the power. Yes, there's one exception, maybe there's 2. 1 times 1 is 1, 2 times 2 is 4. So those do work, but they're exceptions, right? The number 1 mistake that students make with exponents is they multiply the base times the power. One of you will make that mistake. More than one of you will make that mistake. So do not do it. 2 to the 3rd is not 2 times 3. These are the same examples I used yesterday. I'm going to go through these quickly. 13 to the 3rd power would be 13 written 3 times. No, we're not going to do that math. 13 to the 1st power would be 13 written 1 time. So anything to the 1st power is itself, the base. This is why we choose in math not to write things to the 1st power. It just seems like extra work. I said yesterday, you guys are either 12 to the 1st or 13 to the 1st power, or 14 to the 1st power. Anybody 14? Okay. All right. If the exponent is outside of parentheses, technically the base includes the parentheses. For right now, where I only give you positive numbers, it doesn't make a difference. But as soon as the base is negative, it will make a big difference. We'll see that when we talk about negative numbers. Not today. All right. This in yellow is called expanded form. Right? To the left of the yellow is called exponential form because it's got an exponent. Okay? But when it says to simplify, that's when it literally means tell me the answer. And literally multiply 13 3 times. So to do simplification, you must first expand the base written the exponent time, 3 written twice. That's the expansion. I multiply 3 times 3, I get 9. That's the simplification. Therefore, 9 is the answer to 3 squared. All right, expand and simplify. This is 3 written how many times? Grayson, the answer is? You said for homework as well, too. But we now know the answer is? Right. If you said it's 9 because you're doing base times exponent, shame on you. You're saying 9 because you were thinking 3 plus 3 plus 3? Shame on you. Because it's not repeated addition, it's repeated multiplication. So hopefully, Grayson, you will never miss that again after missing it twice, right? There's always that one that causes problem. Typically, you want to know the one that causes the most problem? 5 to the second power. I don't know why that particular one, but guess what kids just want to always put?
10.
They want to put 10. I don't know why that particular one, but I see it all the time. 5 to the fourth is just 54 written one. I said 5 to the fourth. 54 to the first is written as 54. 54 written one time. And parentheses 2 to the fifth is, well, I need 5 parentheses 2s. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Do those numbers sound familiar? 2, 4, 8, 16, 32, 64, 128, 256, 5, 12, 10, 24, 20, 48. Do those numbers sound familiar to you? To anyone? Right? Whenever you go to the store, you've got to buy one of those thumb drive things, right? Memory sticks. Guess what the number is? 2, or it's 4, or it's 8, or it's 16, or it's 32, or it's 64. Whenever you buy a computer, right? Whenever you buy anything that has memory, guess what the numbers always are?
Even.
Right? You don't buy, well, 1 is not even. You can buy an Xbox with a 1 terabyte hard drive, right? Or you can buy one with a 2. Right? I don't think they make 4, but they certainly make something with 512 megabytes of memory, right? Why are these numbers used in computers? 2s. Genevieve? Well, I'm doubling it, but why is everything something 2 to a power? What? That is absolutely right. But why 2, not 3? Wouldn't 1 be easier than 2? For those who don't know, okay, random fact of the day, computers, right? Use a system called, anybody know? Starts with a B. Binary system. A binary system has the word bi in it. Bi means 2. The most basic electronic thing in the world is the basic electronic device in the world is the basic electronic device in the world, the most basic is a switch, a light switch, a toggle switch, a switch. What does a switch do? What does a switch do? Or it does 2 things. It turns out that inside of your cell phone, inside of your Nintendo Switch, inside your computer, inside your television, inside your electronic watch, this is mechanical, it's made up of 2 things. The thing is either on or it's off. It has 2 positions. So when they make this memory, they're making it full of things that do 2 things. It's either on or it's off. And that's why these numbers 2, 4, 8, 16, 32, 64, 128, 256, 512, 10, 24, 2048, so forth and so on. That's why anything electronic, when they have numbers attached to it, generally it's in twos. All right, random trivia of the day. All right, let's get back to exponents. We did these ones that had a combination of different variables that were repeatedly multiplied. Remember, the technique here is to, well, pick either A or B and tell me how many A's do we have. We have A multiplied 3 times, so it's not 3A, it's A to the 3rd power. We have 2B, so it's not 2B, it's B to the 2nd power. So A, there's 3 of them, B, there's 2 of them. Okay? For the ones where we have to use, Jaden, stop, face forward, pay attention. For the ones where we have to use GEMDAS, now, seriously, do it now, face forward. That means you don't turn back around, yes? Are the instructions clear? For the ones that have exponents and addition and multiplication and division and subtraction, absolutely 100%, you need to be thinking of GEMDAS. We do the grouping symbols first. 3 plus 2 is 5. This is the second most common mistake. I said it yesterday. Guess what the student will do who gets this wrong?
4 times 5.
It's just sitting right there. It's really easy and convenient to do. 4 times 5. Unfortunately, you still have an exponent. You have to do the exponent first. The 2 goes to the 5, or to the parentheses technically here, not to the 4. So I need to do parentheses 5 squared, or 5 to the 2nd power first. 5 times 5 is 25. So even though it does say 4 times 5, and you really want to write that, 20 squared is 400. But 4 times 5 squared is 4 times 25, which is only 100. 2 most common mistakes: base times exponent, or when you have a combination of multiplication and exponents, kids will want to multiply first. Don't use the exponent. Today, there's only a few things I need to clean up. One has to deal with the clock, right? So let's clean a few things up. First new thing, where's your sheet of paper? Get it out. All right, follow the pattern. Ready? Follow the pattern. 2 to the 4th and expanded form would be, all right, which is? Which is 16. Let's see. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Okay? Follow the pattern. What's the pattern? What's the pattern? I'm going down by 1. So how many 2's do I write? The answer is 8. Follow the pattern. What am I doing? It's going down by 1. How many 2's? What's the answer? What's the pattern? What's the pattern? I'm not going down by 1. I'm dividing by 2. Well, that makes sense because there's 1 less 2 that I'm multiplying. The inverse of multiplication is, so it makes sense that I'm actually to go from here to here, I'm dividing by 2. How do I go from here to here? So take a guess what I'm going to do with this. Well, let's confirm. So all the pattern, what would I write? 2 to the 1st. Well, that's 1, 2. Therefore, the answer is 2. Is it true? Did I divide this by 2?
Yes.
Okay. Follow the pattern. What would be the next thing?
Divide by 2.
What would be the next thing? So here's the problem. How can you write 0 2's? Right? This says write 2 2's, right? 3 2's. This, by logic now, would say to write 0 2's. But there was another pattern over here, which was divide by 2. Divide 2 by 2, you get
1.
So it turns out that 2 to the 0 power is 1. Well, technically it's true. I got 0 2's because the answer is 1. Write this down, box 1. First and foremost, anything to the 1st power is itself. We choose not to write the 1. Anything to the 1st power is itself. However, anything to the 0 power is 1. Anything to the 0 power is 1, with one exception. And that's 0. 0 to the 0 power we do not define as 1. It's not. It's undefined. So we say that 0 to the 0 power is not 1. It is undefined. So when you see anything to the 0 power, what should you write?
0.
1.
1.
Which is why this clock, the first row says 2 to the 0 power. So 2 to the 0 power we just showed was what number?
1.
So if this is hours is 2 digits. Right now it is 1. Well, no light is lit here, so it's 1, 0. That means it's 10. 2 to the first power is what? So it is 10, 20. What's 2 to the second power? So it's 10, 24. Right there. And that's how you read the clock. I literally just told you.
I know. Listen, I have been, you taught me how to use that twice, and I still have not figured out how
Genevieve,
to
don't do the seconds, they click too quickly.
So, like, if, kind of like, if you know your tens,
It's not necessarily tens place. This is called, if the light is either on or off, guess what kind of clock that's called? It's called a binary clock. It's either the light's on or the light's off. There's only 2 positions. Like a switch.
One question.
What?
2 to the 0 power. So, is that 10 or is that 1 on hours? Is that 10 or 1 right now?
So do you agree that we say time, we have 2 digits for hours, we have 2 digits for minutes, and we have 2 digits for seconds?
Yeah.
How many columns are there? Columns go up and down. 1, 2, 3, 4, 5, 6. So where you're looking at that first column, you're looking at the first digit of time for hours. When you're looking at the second column, you're looking at the second digit of hours. Whatever's going on in the back, please stop. All right. Enough of that side note. That was 2 of them for the day. Let's see some examples. What is anything to the first power? Itself. So therefore the answer is
4.
what is anything to the first power?
10.
What is anything to the first power?
Itself.
Itself. So the answer is 10. What is anything to the first power?
Itself.
So that's 2 times 3, which is in this case 6.
Wow.
What is anything to the first power? So what's the answer? Are you with me? I got like 2 people answering. If you're sitting there and you're not paying attention, shame on you. If you're sitting there and you're like, wow, this is slow class, I wish it would go faster, right? Because you understand it, okay, I'm actually happy about that, right? But if you're sitting there and you're not participating and you're not paying attention, shame on you. All right, X. Hey, what's anything to the 0 power?
1.
This is hard to wrap your head around. How could 4 to the 0 be the same as 2 to the 0? Anything to the 0 power is 1, with one exception. What's the one exception? 0 to the 0 power, undefined. Okay. What is anything to the 0 power? Well, that's the same answer. What is anything to the 0 power? So this one is easy. I don't care what's on the inside. It could be 40 things. I'm going to tell you the test question. I'm going to put 8 things on the inside of parentheses and put it to the 0 power. And I will see 3 people in this class do the calculation. And I will make sure the numbers are ugly. But if you're paying attention, hey, anything to the 0 power is 1.
I remember there was this year in 3rd grade where
Anything to the 0 power, including variables, is 1, as long as x is not 0. Now, I'm not going to trick you on that one. I won't say, well, yes, what is x to the 0 if x is equal to 0, right? That would be a good, question, but I'm not going to put that on test. All right. As long as x is not 0, it's equal to 1. All right. The one exception, right, is the 0. Now, I said 0 to the 0 is undefined. I didn't say anything about 0 to the first, or 0 to the second, or 0 to the 100th. What is 0 to the 100th power?
0.
Why?
Because EP times 0 is
So even if I multiply 0 100 times, I still get
0.
So what's 0 to the first power?
0.
Because anything to the first power is itself. So that's not the exception. The exception is this one. 0 to the 0 is undefined. Undefined. There isn't an answer. We okay?
Yeah.
All right. Box 2. Do it by yourself. Go. Get the whole thing done. Do you know how to do the other ones? Oh, so you need to pay attention to the second one. David, we good? Do you remember doing this last year a little bit? All right, let's see. Upper left to lower right. Go. Give me all 3. 6, 6, and G. 6, 9, G. Right side. What do you got, Avery?
I got 1, 1, and 1.
Oh, man. Kind of boring, right? All right. We okay with anything to the 0 power, anything to the first power? Do we need to do another one, or we got this? All right. Who can give me all 8 answers? Top of your head. Go ahead, Gabby. Go.
Okay, so
Left side, straight down.
3, 15, 15 again, Y, and then all the other ones on the right.
Well, that's a lot of work. Okay. Yes or no? You gotta be brave if you don't. All right, got one last thing to do, and it could be brand new. Many of you might have forgotten this. I did not teach this to you next year, but maybe you've been exposed to it. Okay? But this is absolutely 100% an 8th grade standard. Here we go. Box 4. This needs to go into box 4. What's in this box? Whatever I write up here doesn't need to go. But what is in this box goes in box 4, okay?
Yeah.
Is everyone paying attention?
No.
Okay? Well, I don't know what to do. So I'm going to fall back to everybody see the problem? It's 5 to the 3rd times 5 to the 4th. I don't know what to do here. So here's what we do. We fall back to our other technique, which is expand it out. Let's see what happens. So this first one, 5 to the 3rd, how many 5s do I write?
5 times 5 times 5.
Okay, so 3 of them. So you see what I did? Okay, that's my blue. Times what?
4 5s.
5 written 4 times. Is everybody okay? That's the green. So it's blue times green. Hey, what do you notice? I got lots of 5s. Repeated multiplication is another fancy word for. Repeated multiplication is a fancy thing for exponents. So this is 5 in expanded form. So what could I write? I could write 5 to the 7th if I wrote it in exponential form. Here's the answer. Are you with me? Here's the beginning. Tell me what you notice. Here's the start. Here's the finish. Tell me what you notice. If the bases are the same and you're multiplying, what do you do with the exponents?
Just add them up.
You just add them. So guess what we're going to write in this box?
5 times
The
5 times.
rule for multiplying with exponents. So the rule for multiplying with exponents, it's a paradox. The rule for multiplication says to do what? The rule for multiplication says to do what? And why am I saying it's a paradox? Because to multiply, shouldn't you multiply? But it turns out the rule for exponents says to do what?
Add.
That's why it's a paradox. Write that down.
Well, but to be fair,
Multiplication is repeated addition. Right.
So it's
Agreed. But I'm just saying for most people, when I say, what is the rule for multiplication? My answer, what I expect you to say is add the exponents. This is the official rule. The multiplication of exponents with the same base. This only works if the base is the same. If this was a 3 to the third times 5 to the fourth, can't do it. We'd have to expand and multiply. But if the bases are the same, you rewrite the base and you add the exponents. If the bases are the same, you need to write this down. Box 4. If the bases are the same, rewrite the base, add the exponents. Easy or hard rule?
Easy.
Crazy easy. Crazy easy. We're going to have 4 of these rules. Today we get the multiplication rule. We're going to get a rule for multiplication. We're going to get a rule for, I guess, addition and subtraction. We're going to get a rule for division. And we're going to get this weird one, which is called a power to a power. We will have 4 of these. And they can get jumbled in your head for the first year that you do them. That will be this year, by the way. Free algebra. Do we have everything written down that we need to write down?
Yeah.
Let's do some. Step number 1, if you're multiplying, the first thing you need to ask yourself is, are the bases the same? If the bases aren't the same, you can't do this. Are the bases the same? Yes or no?
Yes.
So add the exponents. What's the answer?
12.
3 to the... You have to ask that as your first question. 3 to 12. Do we need to write this?
No.
We'll see. As soon as these become negative, we will. But all right. Are the bases the same?
Yes.
So what's the answer? Who is confused? Hopefully no one, right? Because it's literally that easy. Oh, by the way, is this a satisfying answer?
No.
It's not. I mean, we didn't really do anything. But
I mean, like,
small or big
solving-
number? Small or big number? Really big number. I mean, if you grab your calculators, which we'll do at the end of class, if you grab your calculator, you do 4 to the 13th power, it's a pretty big number. Right? Pretty big number. It's not something you want to do by hand. All right, here we go. Are the bases the same?
No.
Can't do this. But guess what I will see students do?
Oh.
What would be the student that isn't paying attention, guess what they would actually do? Right? They would probably see this dot and do what? They would probably say 2 times 3 is 6. And then maybe they remember they were supposed to add. So I will have students do that. So let's just see if this is even true. So let's see is 6 to the 5th power, right? 6 to the 5th power. 6 to the 5th power is
7,776.
6 to the 5th power is 7,776. Okay? Well, let's do it the right way. So if you don't have the same bases, you got to expand. What's 2 to the 3rd power? 2 times 2 times 2.
8.
What's 3 to the 2nd power?
9. 17.
What's 8 times 9?
Oh, 50.
What?
72. Solid.
Do you see a problem?
Yeah.
72 does not equal 7,776. So, will you ever multiply the bases, right? Ever? No, never. In fact, the rule for when the bases are the same is you rewrite the base. You don't multiply. What's the answer? So it does work with exponents as well too. Hey, stop, sit. What's the answer? Nope. Remember, we never write things to the first power. However, it is to the first power. So this one is actually c to the 8th. All right. Have a good weekend.
You too.
Jace, have you been exposed to this? Have you been exposed to this? It is really easy, but have you been taught this before? Good. Maybe I taught you something today. All right, e-learners, send me an email if you have any questions. Remember, on Mondays, Sunday night officially, we will start doing this on Microsoft Teams.